Hello. Here I will start with an example. It's an interesting example to consider hypothesis testing. So think about an airline or hotel or whatever. So it allows free cancellation of the reservations made on air flights, and so the free and the airline company knows that uh, the probability of accidental cancellations, like I mean, if the passenger, the reservation holders, the passenger may be sick, or the passenger may truly need to cancel the trip just because of something else, something serious that happens, something else. So that happens with 20%, say. And again, the cancellations are statistically independent across reservations. And so this is the setup, like simply, right? Truly, like usually 20% of customers need to cancel their reservations for something else. Truly, that is a honest cancellation. However, there are some people who abuse the free cancellation policy. So, for example, making dummy reservations, like so reserve everything, like all the seats, or say reserve like almost every day, like and they know they are going to cancel them. Most they know they are going to cancel most of them later, but they're abusing the free cancellation policy. It does not harm, does not cost anything. So here, the airline company tries to identify who is abusing the free cancellation policy. So there are many customers, and the company observes their past record of reservations and cancellations. And we are going to apply the hypothesis testing um, conceptual framework to identify, to reject some customers. So to ban some customers and designate as an abuser. So okay, then let's think about this. Suppose that there are two suspicious customers. For example, say customer A had five reservations in the past, but she canceled three of them. And there is another customer B who made 100 reservations in the past, but canceled 30 of them. Right? There are two different customers records, and among those two, between those two, who do you think is more likely to be an abuser? Who is more suspicious? Guess. So, at the first glance, maybe what you want to do here is customer A canceled 60% of the reservations, right? 60%. 3 out of 5 is 60%, and customer B canceled 30%. So A canceled twice more than B, like in terms of the probability, right? In that sense, I think most of you thought customer A is more suspicious because canceled more frequently. However, we are going to think it the other way, like think it this way. We are going to first assume that they are not abusers. They are not abusing the policy, but still they may need to cancel the reservations for some reasons, right? This could be honest cancellations. Then how can we tell? There is no way, in terms of probability, it is possible. It is possible that customer A and B were really unfortunate, unlucky. So like say car accident happens 3 times out of 5 trips, or 30 times out of 100 trips. That is possible, not 0%, right? Then but not 0%. So we cannot rule that out, but we can calculate that probability. How likely that happens, right? How likely those cancellations are accidental, like honest cancellations. Say, think about this binomial distribution. So it is from the binomial distribution. We considered almost the same example in the binomial distribution chapter. So think about distribution of honest cancellations if you make 5 reservations. Oh, excuse me. If you make 5 reservations, there are some and if you need to cancel the reservation with 20%, then you may need to cancel 0 or 1 or 2 or 3 or 4 or 5. This is the case when 20% of bad luck happens 5 times in a row. Then that probability is 0.03%. It's small probability, but not 0. And most likely is 1. So because you may need to cancel 1 out of 5 reservations, so it's nearly 41%. So and 0 is 33%, nearly 33%. And 2 is still likely, 3 is still 5%. So canceling 3 out of 5 times is still 5% possible. 5% of honest customers would cancel 3 out of 5 times. And then in this way, in this graph, like from this histogram, you can tell the customer will be more suspicious in this direction, right? So canceling all the time is the absolutely most suspicious customers, and the next and the next and the next, and least suspicious is in here. From that idea, we are going to make a cutoff. So let's see what happened or how many customers you have to ban in each case. Suppose that if you ban those customers who canceled all the 5 times, then if you ban these guys, you ban 0.03% of customers, right? And you may put your cutoff here. So ban 4 or 5 times. And then if you ban those who cancel 4 or more times, then a total of 0.67% will be banned, right? So this much will be banned. If you expand the cutoff, then you are going to ban 5.79%. If you ban 3 or 4 or 5 or 3 guys, then you are banning this much, 5.79%. So you have to make your standard considering the potential collateral damage. So you have to ban someone, but when you ban someone, some honest customers are banned because they are unlucky. Seems something unlucky happened to them, right? So then your choice depends on how much you are willing to sacrifice honest customers. That is a basic approach to this decision, and we are going to interpret the percentage as a rank. So customer A is the 5.79% most suspicious customer among all. So like if someone canceled 5 out of 5 times, then like he's top 0.03% suspicious, and 4 times means he is 0.67% suspicious. So it's from the top. 0% is the most suspicious, 100% is the least suspicious. So this guy is top 5.79%. Do you understand? It's getting complicated. So most suspicious from this one. So if you are here, you are within top 5.79% in terms of suspiciousness. You are very suspicious. If you are here, you are at the bottom, and if you are here, you are you are suspicious in the top 25 something percent, maybe 26%. So in that way, you can rank the customers using these probability distributions, and you can calculate how much probability in each rank, in each tier, suspicious tier. And so exactly I said this. Customer A is here, and this much is 5.79. So if you cut here, if you put standard here, then this much, guys, will be banned. That is what we need to consider to understand the hypothesis testing. Okay, I think I will continue from here. Maybe I need to do it again a little bit, but isn't it interesting? So I will consider the other customer in the next lecture. Have a nice weekend and see you later.